Hi, today we're going to learn about absolute value equations. Equations in that literally the only thing that they need to have are absolute value bars and an equal sign. And we're going to look at some basic rules. So there's 4 situations that could arise, but they're not as complicated as it might seem. Really, the only one that takes any extra thought or effort is the fourth. But these three, two solution, one solution, and no solution, actually have straightforward reasons why and why they don't happen. So we need to look at what an absolute value bar actually does. The absolute value of anything can only yield a certain amount of results. The answer to this question will always be something that is positive or greater than 0. So what comes out of absolute value bars? Whatever it is, so let's say it's x. Whatever comes out of this thing, that thing will have to be greater than 0, and it could be equal to 0. So that's two separate cases. The value that comes out of an absolute value bar could be 0, or it could be just positive. So what does that mean? If I take the absolute value of a positive number, like say positive 4, I'm going to get positive 4. If I take the absolute value of a negative number, like negative 4, I'm still going to get positive 4. But if I take the absolute value of 0, I'm just going to get 0. What does this tell me? I will never, ever get a negative number out of an absolute value bar. So we already have our solutions that could happen. When am I going to have two solutions? When I have my absolute value bars, doesn't matter how big or large on what's on the inside. So look at an example like this, 2y minus 7. I don't even care about the 2y minus 7. All I care about is, once I see the absolute value bars all isolated, is it going to look like the absolute value bars equals just some constant positive. And when I say constant, I mean it has to be a number that doesn't change. It can't have a variable attached to it. So let's say it's, I don't know, the absolute value bars equal 9. That would definitely make it have two solutions. And I wouldn't have to check my answers. Now, I say should have two solutions, in that if you do all your algebra correctly, it should have two solutions. Now, of course, if you do your algebra wrong, like you miss an addition or you accidentally do a PEMDAS step wrong, then you might not end up with two solutions. But it should have two solutions. If you have no solutions, that's the one rule that these absolute value bars can't break, is if it equals some negative constant, some constant that is negative. The second that happens, well, the only thing that can come out of the absolute value bars are 0 and positive numbers. If it equals a negative, we broke something. Something is wrong. The answer is going to have no solution. Should it have one solution? This is a very interesting step, to where if you have the absolute value bars equal to 0, then since we're not greater than 0, we can't be a bunch of different positive numbers that could have multiple different things that could happen. 0 gives us one solution, because absolute value bars give me a plus or a minus as an answer of what could come out, and the 0 has no opposite or negative or positive. It's just itself, so one solution. Might have one solution, might have two solutions. I would say the fourth is the most annoying to approach, simply that most mathematicians are very lazy, and we don't like to do the extra step of checking our work if we are very confident in our mathematics. Now, as a teacher, I should probably be telling you should always check your work. But if you done all your math right, then if you should have two solutions and you end up with two solutions, you're probably right. If you should have one solution and you end up with one solution, you're probably right. And if you have no solution, it should be very, very clear when you equal a constant negative. When you have might have one solution, or you might have two solutions, it's annoying because, yes, the only way you can tell if it's either or is if you check your answers. Plug it back into the original equation and see if they work. And this happens when your absolute value bars, not only is there a variable on the inside, so let's say, copy this one, 2y minus 7. Not only is it 2y minus 7 on the inside of the absolute value bars, it equals another variable on the outside, or another set of expressions. So let's say on the outside it's 3y plus 2. Then I look at this, y, I could plug stuff in for y to make 3y plus 2, this side of the equation. It could be positive. Sometimes it's positive, like if I plug in 1. 3 times 1 is 3 plus 2. That's a positive number. Or it could be a constant negative, Like if I plug in a large enough negative number, like -1, 3 times -1 is -3. -3 plus 2 is -1. So sometimes 3y plus 2 is positive, sometimes it's negative. And let's see, could I make this 0? Yeah, if I plugged in the reciprocal, -2/3, then the 3's would cancel. I'm left with -2. -2 plus 2 is 0. So it could also be 0. It has so many different possibilities that could happen simply because there's a variable where we can plug in any number possible. We are going to have to check our solutions there. But let's go through the basics. Let's see, we have 2 solutions. Know for sure we should have 2 solutions? Well, because I put in this section, but you don't actually know if you're in case 1, case 2, or case 3, or case 4 until you've done step 1 of our checklist. Step 1 is always isolate the absolute value bars. Step 2 will be check if possible after I've isolated. So looking at this right now, if I wasn't super confident, I wouldn't be able to say, like, and bet my life on it if I only glanced at this for 1 second, that this has 2 solutions. Instead, we should isolate its absolute value bars. Get these bars alone. Why are they not alone right now? I'm adding a 5, and I'm multiplying a 4. Can't have that. We need these all by them lonesome. So, let's -5. And then we get 4 times the absolute value of 2y minus 7. And these are just the basic PEMDAS steps to get isolate anything you want on its own. You flip PEMDAS, make it sad meeps, do addition or subtraction first, then multiply or divide to get the thing alone. So we subtract first, and we get the absolute value 4 times 2y minus 7 equals 9 minus 5 is 4. Divide both sides by 4. And we get the absolute value of 2y minus 7 equals 1. So this is option 1. Should have 2 solutions because my absolute value bars, all by them lonesome, all by their lonesome, equals a constant positive. The constant positive being 1. So we've isolated. Step 2, check if possible. I equal a positive number, that is A-OK. So check, check. And if it is possible, we split and solve. We only stop if it's not possible, like no solution equals a negative. So it is possible, split it into its 2 possibilities. 2y minus 7 equals the original, and 2y minus 7 equals the opposite of 1. And then we solve. So add 7, divide both sides by 2. I'm running out of space, I wrote too big. Let's shrink this just a tad bit. Yeah, good enough. So, add 7 to both sides, add 7 to both sides. The 7's are gone. 1 plus 7 is 8. -1 plus 7 is 6. That equals 2y. That equals 2y. Divide both sides by 2. And we get y equals 4. And y equals 3. And because I'm confident in this step right here, the isolated part, I isolated, and step 2 checked if it's possible, yes, these should be my 2 solutions. I shouldn't have 1, I shouldn't have none, I should have 2. And if I did all my math right, I'm good to go. Now, if you're taking a test or you're taking a quiz, you should absolutely plug these back in and plug them back into the original equation for sure, just to make sure that they do work. But if you're just doing some homework or just you're very confident in your algebra, these are our answers. We don't know if this is going to have 1 solution or no solution. Let's see. Always do the opposite of PEMDAS to get things by itself. So one thing you don't want to do is 5 minus 3. I see that very often. You see the 5 and the minus 3, but this is a 5 minus 3 times all this stuff, which means this is technically 1 term. That means 5 and minus 3 times this whole thing are not like terms. We cannot subtract these. Instead, let's get rid of the 5. Do adding or subtracting first that we're able to. And we get -3 times the absolute value of 2 plus 2w equals -12. Divide both sides by -4. So at this point you might be thinking, oh, there's a -12 here, or there's a -7 here. It has no solution. Well, negative divided by a negative, I get, oh, why did I divide by -4? I should divide by -3. There we go. And I get -4. divided into negative 12 gives us positive 4. And once I've isolated, I see, yes, this is possible. Positive 4 is my positive constant. This is a-okay. I've broken no rules. So, we split it. I'll do this off this side. This becomes 2 plus 2w equals the original, and 2 plus 2w equals the opposite, negative 4. And we get, let's see, minus 2, minus 2, minus 2, minus 2. And we get 4 minus 2 is 2. Negative 4 minus 2 is negative 6. This equals 2w. Divide both sides by 2. And we get w equals 1 and w equals negative 3. And those should be our answers, 1 and negative 3. Next section, we're at no solution. So, the steps are still the same. Isolate the absolute value bar. So even though I put in this section of no solution, we don't know. So pretend we don't know that this has no solution. When would it have no solution is when my absolute value bars equals a negative number. Let's see if that happens. So again, do not do 3 minus 5. Minus 5 times this thing is one whole term. So that is not a like term with 3. Instead, move the 3 over first, because we're able to, adding and subtracting, and we get negative 5 times the absolute value of 2d minus 3 equals 1. And then divide both sides by negative 5. And we get the absolute value of 2d minus 3 equals negative 1/5. And then we stop. Check to see if this is possible. My absolute value bars all isolate equal a negative constant. This is not possible. Absolute value bars only yield 0 and positive numbers. Negative 1/5 is neither of these things. So it is not possible. We can't split and solve. We simply stop and say no solution. That is the null set, so the empty set, which is representative of the phrase no solution. So that's a way to answer saying no solution. This is a way to answer saying no solution. Empty set and no solution. Then we have one solution. Let's see, when could this happen? Step 1, isolate the absolute value bars if possible. They are already isolated. Step 2, check if possible. Absolute value of 0 equals 0. This definitely happens sometimes. So we split and solve. We take 3x minus 9 equals the original, and 3x minus 9 equals the opposite of 0. But there is no opposite of 0. It's not even positive. It's not negative. So this is really the only case that could happen. You could write it twice if you really feel like it. The opposite of 0 is 0, but that would be redundant and a waste of space. So I'm only going to solve it once. Add 9. We get 9 equals 3x. Divide both sides by 3. And we see that x equals 3 is the one and only solution to this equation. And finally, these ones I can already tell right off the bat that I'm going to have to check my answers, even without isolating first. They're already isolated, but even if they weren't, unless this variable on the other side is going to cancel out, like let's say maybe I have plus 3x on this side and I subtract both sides by 3x. If that were the case, then yeah, I would say the variables are gone, so the absolute value doesn't equal two variables. But in this case, no matter what, I'm stuck with a variable on the other side of the equation. I could have one answer, I could have two answers, maybe I have no answers, it happens. I'm going to have to check my answers no matter what. So it's already isolated. Step 1 is done for us. Step 2, check if it's possible. Well, multiply this by 1, and 3 times 1 plus 1 is a positive. So yes, it is possible sometimes. That's all I need to know, is that are there times when it's possible? And yes, there are. So we split it. X minus 2 equals the original, and x minus 2 equals the opposite of 3x plus 1. The opposite of 3x plus 1 is negative 3x minus 1. So you have to negate the entire side. And then we do our math. Let's see. I want to get all the x's to one side. Let's say minus x to this side. So that means minus 1 on this side. That cancels, that cancels. I'm left with 2x equals negative 3. Divide both sides by 2. And I get x equals negative 3 halves. And then I go over here, and let's see. I've got, let's add 3x to both sides. Add 2 to both sides. That's gone, that's gone. We have 4x equals negative 1 plus 2 is 1. So divide both sides by 4. And we get x equals 1/4. And now, because there were variables on both sides, I need to check the original equation, 3x plus 1, and make sure that these two values don't break anything. So one of these could give positive values, one of these could give negative values, both of them could be true, both of them could be not true. I'm not sure yet. The only thing that can't happen, again, is the absolute value bars equals a negative number. So let's see, what makes this side of the equation negative? If I plug in 1/4, that's a positive number. 3 times 1/4 is 3/4. That's just a positive number plus a positive number. This one's A-okay. So check, that one's hasn't broken anything. But negative 3 halves. Negative 3 halves times 3 is bigger than 1. Let's see. Let's see how big, much bigger. 3 times negative 3 halves plus 1. That's going to be negative 9 halves, and 1 is really 2 over 2. That's going to be negative 7 halves. That is most definitely a negative constant. So 3x plus 1 becomes the negative constant, negative 7 halves, when we plug in a negative 3 halves. So this is broken. We call this situation one solution, where this is the true solution, and this is the extraneous, the false solution. Extraneous, false solution. So this doesn't make it true, this one does make it true. One solution. Well, let's see what happens in this example. Again, we have a variable on the right side. I could plug things in that make this true, so it's positive. 3 minus 1, that's a positive number, so that doesn't break anything. What about 3 minus 3? That's 0, that doesn't break anything. But 3 minus 4, the second I go over the threshold, not okay. That would make this side of the equation negative. So let's see what happens. My absolute value bars are already isolated, so I split. 4x plus 3 equals 3 minus x. 4x plus 3 equals the opposite of 3 minus x, which is negative 3 plus x. Let's solve both sides. So let's say we add x, subtract 3. 3's are gone, 3's are gone. Added x to both sides, so I'm left with 5x equals 0. And if I do that, divide both sides by 5, 0 divided by 5 is still 0. X equals 0. And then next, we have 4x plus 3 equals negative 3 plus x. Let's say we subtract x from both sides. So minus 3, minus 3. That's gone, that's gone. I'm left with 3x equals negative 3 minus 3 is negative 6. Divide both sides by 3, and we get x equals negative 6 divided by 3 is 2. So let's see, are both of these answers okay, or is one of them false, or are both of them false? If I plug in 0, 3 minus 0 is 3. 3 is a positive number. This one's good. X is negative 2. Let's see. 3 minus a negative 2 looks like 3 plus 2, which is 5, another positive number. So both of these actually work. Even though we had a variable on both sides of the equation, we still got two solutions. So To wrap it up, when you have variables on the other side of the equal sign, you have to check your answers. When you equal 0, you should get one answer. When you equal a negative number after you've isolated, no solution. And again, after you've isolated, must isolate the absolute value bars first. Check to see if we get a positive number, like 1. 2y minus 7 equals 1, or the absolute value of 2 plus 2w equals positive 4. If that happens, you should have two solutions.